This is how our setup will look like. As you can see, we'll create 4 CentOS VMs with minimum of 3 CPUs and 3 GB of RAM. And for masternode, maybe you might want to have a bit higher configuration. In our example, I have created all these 4 VM instances on Google Cloud. In that, one VM will be configured as masternode and other 3 will be configured as Kubernetes worker nodes. So that's about the setup will look like. Now, let me show you the 4 VMs I have created inside Google Cloud. So here is a snapshot of 4 Google Cloud VM instances. So creating this VM is very simple. I'm guessing most of us are familiar with it. In case if not, don't worry. I have that covered in the demo. As you can see, all 4 VMs has internal and external IPs. You can log into the server by clicking on the drop-down next to SSH. Personally, I prefer connecting using Cloud Shell to connect to these VMs. Once you have the VMs created, then next step is to disable SWAP and SELinux, which is step 2. In this slide, we'll first disable SWAP, then SELinux on all nodes, and finally we'll reboot the VMs to make sure it comes clean. So to disable SWAP, we'll use the swap off command with the -a option. Also, check there is no swap related entries in FS tab. If there are, please do remove or comment it out. And one of the main reasons why we need to disable swap is the performance related. Next thing is disable SELinux. You can do that by using set enforce 0 command. For SELinux to disable permanently, you need to update config in SELinux config file as shown above. So you have to disable SELinux until SELinux support is improved in the kubelet. You need to disable SELinux and swap on all nodes including Kubernetes master and worker nodes. Once that is done, it is good to reboot all the nodes to make sure it comes up clean. And make sure swap and SELinux are disabled post reboot. So that's about the swap and SELinux. Next comes the installing Docker. Kubernetes supports multiple container engines such as Docker and Rocket. Since a Docker is most popular and widely used container engines across, so we'll go with installing Docker. If you are using CentOS VM on Google Cloud, then please go ahead and install Docker using yum install, as you see in the screen. In case if you are using Ubuntu, you need to use apt-get command instead of yum. You can find those commands on Kubernetes documentation or just Google for installing Kubeadm. After successful installation of Docker, start the Docker service and enable the service to start at boot time. We need the Docker container engine on all servers, including master and the worker nodes. So you need to install the Docker and then start and enable Docker service on all servers. Once that is done, then we can install other 3 applications, which are Kubeadm, Kubelet, and Kubectl. I guess you are already familiar with what this software application does. But just a quick review if you forgot this. First, Kubeadm. It is responsible for bootstrapping the Kubernetes cluster. Next, Kubelet. This component runs on all machines inside your cluster and does things like starting pods and containers. Finally, Kubectl. And this is a command line utility through which we can manage the cluster, such as creating, deleting, displaying, and updating various Kubernetes objects. So all these packages are not available in default OS repository. So we need to create one repo file inside repos directory. This repo file consists of a location where all above 3 Kubernetes related packages are available. Once you have the repo file in place, then you can start installing all 3 packages using yum install on CentOS and then start and enable kubelet service. You need to perform this on all VMs including Kubernetes master and the worker nodes. In case if you're setting up Kubernetes on RHEL and CentOS, then there is one more extra step need to perform, and that is this. This is used for fixing issues where traffic is being routed incorrectly due to IP tables being bypassed. So go ahead and update config as you see on the screen. Once you're done with it, now let's move on to the next step where we will initialize Kubernetes cluster. Configuring Kubernetes master node is very simple. It is just one simple command. We can do that by Kubeadm init command as you see on the screen. I guess you might be wondering what is that pod network thing here. This is required if you wish to use Flannel pod network add-on. If you ignore this, then kubedns pod will not start. We'll talk about this pod network in next slide. For now, use the exact command to set up the Kubernetes master node. So upon successful execution, we should see something output which is similar to this. In the command output, you will see two things. First, we need to execute these three commands as a regular user in order to start using kubectl command. Second, it will print join command. You need this command to execute on worker nodes to join them to the cluster. We need this for the future purpose. For now, you need to save it at some secure place. You will see me using this command in a second. So that's all with initializing the node as a master node. Now moving on to the next slide where we talk about configuring pod network on master node. It is required to install a pod network plugin after you initialize the master node. So it will help the pods to communicate with each other. It is necessary to do this before you try to deploy any applications on your cluster and before kubedns starts up. And there are different types of network plugins as we discussed previously. In this case, we are using Flannel network plugin. If you remember, we have used pod network CIDR to the Kubeadm init command in the previous slide. That's because it is required if you are using Flannel network add-on. So you can install pod network using kubectl apply command followed by kubeflannel YAML file as you see on the screen. So to confirm if pod network is installed, you can do that by checking kubedns pod is running by using kubectl get command. That's about the pod network. Now the final last sixth step, and that is joining worker nodes to the cluster. It is very simple. So to join the worker nodes to the cluster, we need the join command we noted down from Kubeadm init command output in previous slide. Here is a join command that was provided to us during initializing the master node. So just execute this exact command on worker node to join to the cluster. So upon successful execution, node will join the cluster. It is that simple. And the token in join command expires after 24 hours. In that case, you can create new tokens by using Kubeadm token create print join command as shown above. It is advised you to not to use this frequently as it will create new tokens every time you run it. So now we have Kubernetes master and the worker nodes and all components are configured and ready. And now it's time to make sure everything is working correctly, and for that we'll test with deploying a sample application in the next slide. Currently we are on the master node. So to display the nodes inside the cluster, we'll use the kubectl get node command. As you can see from the output, we have 4 nodes. One is master and 3 are worker nodes, and all are in ready state, which is what we are expecting. Overall, cluster looks healthy and working perfectly. Now let's deploy a sample application and check if there are any issues with it. So to create a deployment, we'll execute the kubectl run command followed by sample application. From the command output, it is confirmed that deployment has been created successfully. Now To display the pods which are created as part of this deployment, we will run the kubectl get command. As you can see, there is one pod which is created and running successfully as part of this deployment. Based on above testing, cluster is running with 3 worker nodes and we are able to deploy sample application successfully. So far in this video, we have discussed about what is Kubeadm and what are some of the commands related to Kubeadm and what are the 6 steps that are involved as a part of configuring Kubernetes cluster using Kubeadm. So before we end this video, let's review some of the important points that we discussed in last few minutes as part of the summary. So coming to the summary, in this video we first discussed what is Kubeadm and what it does. So Kubeadm is a command line utility which helps us with installing and configuring Kubernetes cluster. Then we discussed about Kubeadm commands such as Kubeadm init to initialize the Kubernetes cluster, Kubeadm join to join the worker node to the cluster, and more. After that, we discussed about the 6 steps involved in creating Kubernetes cluster. They are: first, we need to create the VMs. In our case, we have created 4 CentOS VMs, where 1 is master and 3 are the worker nodes. So once the VMs are up and running, then we disable SELinux and SWAP on all nodes. After that is done, we install the Docker, Kubelet, Kubeadm and Kubectl on all nodes and make sure Docker and Kubelet is enabled and started on all nodes. Then we initialize the master node with Kubeadm init command. After that, we configured pod network add-on on master node. So we use Flannel in our setup. Finally, we have joined worker nodes to the cluster by using Kubeadm join command. So those are the 6 steps that are involved as a part of configuring Kubernetes cluster using Kubeadm. And we also did some testing to make sure our setup is correct. And it did work as it should be. So that's about configuring Kubernetes cluster using Kubeadm. And now coming up, the actual demo, where we will perform exact steps to configure Kubernetes using Kubeadm. And thank you so much for watching this, and I hope to see you in the next video.